Hello guys, welcome back, and my name is Edison, and today I've prepared something for you, which is how to use multi-channel ADC in STM. That's true. And what I'll be doing, I'll be measuring the ADC from some ADC values from the potentiometer, and also the internal temperature sensor of the MCU. And with the help of the LCD, I'll also display the measured values. So we shall create a new project. So the first thing that I'm going to do is clear the pinouts, and again I'll show you how I have connected my potentiometer. So as you can see, this is my potentiometer that will be varying. This is the LCD. So when you look at this side, the blue wire is connected to 3.3 volts, and the center, which is the signal, is connected to A0, and the other side of the potentiometer is grounded. So for this, I'll explain to you in the during pinout configuration. So I'll first go to ADC and configure ADC input 0. So this is the pin connected to the potentiometer, and also I'll go down and check on the temperature sensor channel, and below here under parameter settings, I'll go to number of conversions. There are two conversions, that is the ADC from PA0 and also the temperature sensor. So then I'll enable the scan conversion mode, should be enabled, and again I'll use DMA. So I'd like to have a continuous DMA request, but from here you cannot enable the DMA. So you go to system core, and a DMA you add and select the ADC1. So and then the mode, make it circular mode, and then back to our ADC. You can see now you'll be able to enable the DMA request, and then we want to have a continuous conversion mode. And then from there, since we have two ADCs, so the first rank is to read from channel 0, and 3 cycles are enough for that. Then I'll have the second rank for the temperature channel, and we can have for 80 cycles. So from here I'll go to DMA to NVIC setting and enable the ADC1, ADC2, ADC3 interrupt. So and now the remaining pins are for the LCD. So I'm going to use PC3 as a D4. So for you to use the library for the LCD, you have to name the your pins using this convention D4, D5, then D6, then PC0 is connected to D7. So D7. So I'll have my PA1 as the RS pin for the LCD, and I'll have PA4 as the enable pin for the LCD. so it is A. So remember to name your pins as follows for the LCD. So then I'll have PA5, which is as our output. We might use it in the code, and this is connected to a green LED. So from there we are good to go. So, or maybe we can enable the high-speed clock and also the low-speed clock. So then we go to project manager, give our code a name, multi-channel channel ADC tutorial. Then I'll be using Carrier Vision. So now we generate code. So now we open our project. So the first thing to do here is to add the LCD library files to our project. So I'm going to copy this. It is in Documents, CubeMX, or ADC multi-channel tutorial, and call. Then I'll paste them here. Drop the .h file and also drop the .c file there. So then we go back to Carrier Vision, and you add existing files to the group. Go to where you have copied the .c for the LCD and you add. Then build your code to check for any errors. So our project has 0 errors and 0 warnings. So open the main, and in the main function add the header file for the LCD, my is stm my LCD 16:2.h. So from here let's have our global variables, and the variables I'll first have is weight 16 the ADC values. So this will hold the two ADC value, the first one from the potentiometer and the other one from the temperature sensor. So there will be 2, and then I'll have character hold, this will have 10. Let's make it 20. So this will hold our buffer, and then from here I'll have 2 double values, that is port value, and I will initialize that to 0.0, and also temperature value, and I will initialize that to 0.0. So from here we'll start our ADC with DMA. So I'll ADC start DMA, and the first is the type def for ADC. We are using ADC1. Then here we have int32 _t pointer, and this data be stored to ADC values. Then there are 2 bytes of data. Then under functions, go to ADC .c, and you have this function. This is a callback. This callback help us know when the conversion is complete. So I'll copy it in my main.c, and the user code begin for. And what I want to do here, if the conversion is complete, you want to first stop the DMA ADC DMA ADC stop. With DMA you have to stop, and you're stopping the ADC1. Then from there ADC. Then from here I want to have values. Now you can read our values. So our port value will be equals to, you can cast this into double, that is ADC value 0. Then you want to divide this by 4095 so that we can map it with the 3.3 volts, then times 3.3. So why 4095? Our ADC is 12-bit, so when you do 2 to the power 12, you get 4096. So the maximum value will be 4095 since it starts from 0. So it will be 0 to 4095. So the 4095 will represent 3.3 volts. So then from there we have a temperature. Our temperature will be equals to, we also wanna cast this into double, ADC value 1. So from there we want to convert now this to the maximum input voltage, which is still 4095. So we are going to multiply with, we are going to divide by 4095, then you multiply by that 300. So this is in terms of millivolts. So I want to get the millivolts because the conversion, the mapping uses millivolts. So how do we convert the temperature, this temperature value, to the real temperature that is now being measured? So we can find this into the data sheet. So we are going to the data sheet, and let's look for temperature. So under temperature sensor, you will find that the temperature sensor has to generate a voltage that varies linearly with temperature. So the conversion is between 1.7 and 3.6. So the temperature sensor is internally connected to the same input as VBAT. So ADC1 input 18, which is used to convert the sensor output voltage into a digital value. So you see that you cannot measure VBAT together with the temperature because they use the same port. So let's look at our manual and just search for temperature. You'll see temperature sensor, and the temperature sensor you'll see the formula of how to calculate the temperature. So I'm going to copy this to my project. So the first value is the Vsense. So Vsense is now this temperature, and the next one, V, is the voltage at 25 degrees Celsius. So let's go back to our manual, and you'll find that V25 is the Vsense value for 25 degrees. So the average slope is equal to average slope of the temperature versus Vsense curve given in millivolts. So that is why I converted now the voltage to millivolts. So we are being told to refer to the electrical characteristics in the datasheet for values of V25 and the average slope. So I'm going to copy this and open the datasheet, and I'm going to search that there. And here we are. So you find that the average slope is 2.5 millivolts per degree. So we go back, we copy this here, and then we want V at 25. So go back to our datasheet, and you find the voltage at 25 degrees is 0.76 volts. So if you convert this into millivolts, that will give you 760. So 760 millivolts. So from here, so our new temperature value will be temperature minus 760 divided by 2.5 plus 25. So then after this, we want to start the DMA again now. HAL Adc Start Dma. So type def is HADC1, and this is unit .2, and then we have ADC value, and these are 2 bytes of data that will be stored in the ADC buffer. So from here, I want to go to the main function, and under here I'm going to use LCD. In the first line, I want to print LCD print port value, port value equals, and I'm going to print the port value. So it is a float type, so the port value is port value, and I'll have 3 decimal places. So these are functions in the in .c. So you'll find these functions here. So let me go to the main, and open my LCD 16:2. You'll find these functions here. You can print integer, you can print float in the first line. So this tells you that what comes next will be printed in the first line. So going back to our main, I also have in the second line LCD print LCD second line. So what follows will be printed in the second line, and then LCD 16, we want to print temperature. So we can maybe reduce this temperature, temp equals, then we have LCD 16 print float, and in here I'll have the temperature, and I also have I'll print 3 decimal places. So I want to delay this for a bit. I'll delay for 100 milliseconds, then LCD 16 clear. So I want to clear the LCD. So one thing that I have not done is initialize the LCD. So I'm using the LCD in 4-bit mode. So what I'll just do, I copy this and paste it here to initialize the LCD in 4-bit mode. So let's now build a project to see whether you have any errors. So we have 0 errors and 0 warnings. So I'm going to flash the code to our board. So let me add the delay to be 1 second and build the code. So the code has 0 errors. So let's now download the code to our board. So just to point out something, the DMA runs independently of the while loop, so you don't have to put it in the while loop, as you have instructed to continue transferring the data, so in continuous mode. So in the while loop you can do something else. This is the greatest feature now of DMA. So let us manually reset the board. You can see that you have the port value and the temperature displayed. So I'm going to start with my potentiometer here. So as I vary the potentiometer, notice what is happening to the port value. So the port value is increasing from 0 to 3.3, and again, since the temperature sensor is inside the MCU, I'm going to place my finger on the MCU and notice what happens on the MCU, on the temperature. So you can see that the temperature is increasing. So thank you guys for following up with me. This tutorial was a success, and if you have any question, you can leave it in the comment section. Don't forget to subscribe, like, and even share with your friends. So in the next tutorial, I'll be coming to you with how you can use your USB drive with the MCU. You open either a .text file or a CSV file and store some dynamic data in it. So I'll see you in the next tutorial. Have a nice time.